Okay, so let's talk about simplification of some algebraic fractions today. Let's say that the question is, this is the first question, x squared plus 8x plus 15 divided by x squared plus x minus 6. And you have been asked to simplify this. So in order to simplify a fraction, we need factors in both the numerator and denominator. So let's just try factorizing both the numerator and denominator. So we have to do the middle term breaking thing in both numerator and denominator. So what would it be? 3 into 5 is 15. So we can write it as x squared plus 3x plus 5x plus 15 divided by, and what are we going to get for the denominator? X squared and minus 6. And how should we break down the middle term? Plus 3x and minus 2x, because when we will multiply these two, we will get minus 6x squared. When we will add this, we will get x only. Okay, let's try factorizing the numerator. I can take x common, I will have x plus 3. I can take 5 common, I have x plus 3. These two are same, this means we are going in the right direction. And denominator would be again x common, x plus 3 minus 2 common, x plus 3. So the factors of numerator are x plus 5 and x plus 3. And for denominator, we have x minus 2 and x plus 3. Now we have both the numerator and denominator written as a product of factors. So I can just cancel out the same ones. And finally, the answer is x plus 5 divided by x minus 2. This is the answer, right? Did you understand this, Sunny?
Yes, I understand.
Okay, let's talk about another example. Let's say this time the question is 5x divided by x squared plus 7x minus 18 divided by 5x over 2x plus 18. This is the second question. Okay. Now, whenever you have been asked to simplify an algebraic fraction, your working is similar, but whenever you come across this sign, this divide sign, you need to do something. The fraction or the term, the expression before the divide sign would be written as it is, okay? Then you need to convert this divide sign into a multiplication sign, and once you do that, you need to write down the reciprocal of this fraction. So reciprocal of any fraction is basically flipping the numerator and denominator. So 2x plus 18 is in the denominator. It would become 2x plus 18 divided by 5x. Did you understand this?
Yes.
Okay, very well done. Okay, now let's cancel. Oh, this was 5x. Okay. Acha, we can cancel out directly as well, but it's better that first we write down all the factors and then we should cancel it out. Okay. Let's talk about the first fraction. So in the denominator of first fraction, we have x squared plus 7x minus 18. So what two factors are coming to your mind such that when I multiply them, I get minus 18. When I add them, I get 7x.
9 and 2.
Very good. So it would be x squared plus 9x, because we have plus here, minus 2x minus 18. And this would become 5x divided by, I can take x common, x plus 9 minus 2 common, again x plus 9. And finally, it would be 5x divided by x minus 2 and x plus 9. Okay, so we are done with the factorization and simplification of the first fraction. Let's talk about the second one. Can we factorize this part, the numerator of the second fraction?
Yes, by taking 2 common.
Very well done. So it would be x plus 9 divided by 5x. Okay, so finally we will have 2 into x plus 9 divided by 5x. So I can write it 5x into 2 x plus 9 divided by x minus 2 x plus 9 and 5x. 5x and 5x would be cancelled, x plus 9 and x plus 9 would be cancelled, and finally we have 2 divided by x minus 2, right? So did you understand the simplification?
Yes.
Okay, very good. Acha, let's talk about some more. Let's talk about this example now. We have 2x minus 6 divided by x square minus 4 multiplied by x plus 2 divided by x minus 3. Okay. So we need to simplify this. This is a fraction. In order to simplify fractions, what we need to do is we need to first factorize everything. Okay. So let's start our factorization with the numerator of first fraction. I can take 2 common, so it would be x minus 3 and then divided by, and let's factorize this. What would be the factors of x square minus 4? Can we take something out? Is there something coming in common in both the terms, x square and 4?
We can like apply the identity.
Very good, well done. So we know that a square minus b square is basically a plus b into a minus b. This means that x square minus 4, which can be written as x square minus 2 square, is x minus 2 and x plus 2. So I can write it as x minus 2 and x plus 2. And now I have rest of the thing. I cannot factorize the second fraction, that's already simplified. So x plus 2 and x plus 2 would be cancelled, x minus 3 and x minus 3 would be cancelled, and we are left with 2 divided by x minus 2. Okay. Let's say that the question is minus 1 divided by x into x minus 1 plus 1 over x minus 1. Let's say this is your question. How do we simplify such terms when we have addition sign? Is it
We
yes?
take LCM of the
Very
denominator.
good. Yes. Is it pehle we had multiplication and division signs, right? This time we have a different sign. We need to take the LCM. How do we take the LCM? Okay. So we know that this is basically an expression in which one of the factors is x minus 1. And here we have x minus 1, right? This means that we need to take the bigger thing out. Since x minus 1 is coming here as well, so the LCM would be x into x minus 1, right? Is this okay?
Yes.
Okay. Now we need to multiply 1. So this would be minus 1 plus. We need to multiply x with this in order to get the same denominator. So we will multiply x in numerator as well. And finally, this would be x minus 1 divided by x into x minus 1. I see that x minus 1 is coming common. So the answer would be 1 by x. Did you understand this, both of you, Saneem and Turhan?
Can
Yes.
you please explain this again? The
Yes,
second
sure.
part.
Sure. Okay. So we had this, right? Once we had this, I just wanted to rewrite it just so it made more sense. So can I write x first and -1 after that?
Yes.
Okay, and since the denominator and numerator factor is same, so I can just cancel these out and I'm left with 1 by x.
Okay.
Okay, perfect. Okay, let's talk about some more examples. So let's say we have another question which says 1 divided by x plus 2 by 2. Again, we have a division sign. So what is the rule? This number will come as it is. Division would be changed to multiplication. And we need to find the reciprocal of this. Reciprocal of any fraction is the flipping of the interchange of numerator and denominator. This would become the numerator and this would become the denominator. And yes, the answer is simply 2 by x plus 2. Right? Did you understand this?
Yes.
Okay. All right. So let's do this question. Let's say we have x square minus 4x divided by x square minus 7x plus 12 plus 1 minus x divided by x minus 3. Okay. Again, the question would be to simplify, right? In order to simplify, even if it's a simple algebraic expression, even if it's not a fraction, you need to find the factors just so you are able to cancel them and then you would be having a simplified answer. So in order to simplify this, we need to work with both the fractions separately. Let's talk about the first fraction. Let's start our working with the numerator of first fraction. So I can take x common and I will have x minus 4. And now if I talk about the denominator, I need a number such that when I multiply, I need two numbers such that when I multiply them, I get 12 and when I add them, I get minus 7. So which two numbers come to your mind? Yes, Turhan? Any idea?
Could you repeat that?
Okay, so we want to factorize the denominator, okay? In order to factorize the denominator, we need to do middle term breaking, right? Which we have discussed yesterday as well. So we basically need two numbers such that when we multiply them, we get 12. And when we add them, we get minus 7. So what two numbers come to your mind? Think about it, take your time.
3 and 4.
Very well done, excellent, okay? So it would be minus 3x and minus 4x because we have minus 7, right? Very good. So it would be x minus 4 divided by, I need to factorize the denominator now, so I can take x common, x minus 3, and now I can take minus 4 common, so it would be x minus 3. And since these two are same, it means we have done it correctly. Finally, we will get x minus 4 into x minus 3. Okay, so we are done with the simplification of first fraction. There's no point in simplifying the second fraction because it's already simplified. X minus 3 plus 1 minus x divided by x minus 3. Okay, now before taking the LCM of the two fractions, I can simplify every fraction, right, on its own. So if I talk about the first fraction, I can cancel these two out. Now I have a simplified version of the first fraction, that is x divided by x minus 3 plus 1 minus x divided by x minus 3. Now what do I see? I see that the denominators of both the fractions are same. So I don't have to take the LCM, okay? I can just directly write same denominator once and I can just add the two numerators. So it is x minus x, these two would be cancelled and the answer is 1 over x minus 3. So did you understand this, both of you?
Yes.
Yes.
Okay, all right, perfect. So that is it for this chapter. We'll talk about more fractions once we are done with the next chapter, that is indices. Okay, let's talk about the next chapter, that is indices. Okay, so let me just talk about a very basic thing and then we'll do some rules. And yes, this chapter is very, very easy. Okay, so right, so basically what you need to understand is that if I write something this way, a would be the base and x would be the power, right? You can also call x as the exponent, but this is the basic idea. Now we will be basically talking about different rules in this chapter, and you will see how to play with such numbers. Okay. Okay. So this basically is power, or you can call it index, or you can call it the exponent, right? But this is the basic idea. Indices, since the chapter is of indices, so we can think about it as the index, right? So let's talk about some rules. Let's talk about some rules and then we would be knowing how to go about this chapter. Okay, so just give me 1 second. All right. So let's talk about the first rule. Just make some lines. Okay. Let's talk about the first one. So the first rule says let's say you have a to the power m multiplied by a to the power n. Now, what do you see? You see that you have two numbers that are being multiplied. The bases are same and powers are different. So the rule is you can write it as a m plus n, right? When bases are different, when bases are same and they're being multiplied, you can just write the expression with base one time and add up the powers. So if we talk about the second rule, it is you have a fraction. For this, you can write a m minus n. Okay. For example, if we talk about an example of this, let's say we have 2 to the power 3 multiplied by 2 to the power 4. Now, what do we see? We see that our bases are same. Since bases are same, I can write the base once only. Since they are being multiplied, I can just add the powers and I can write it as 2 to the power 7. Let's talk about an example for this one. Okay, let's say we have 3 to the power 5 divided by 3 to the power 2. Now, since we have same numbers that are being divided and their powers are different, I will write down the number once only. The power in numerator minus the power in denominator, and this will give me 3 to the power 3, right?
Yes.
Okay. So these were the two rules. Let's talk about some more. Let's say this time you have two numbers that are being multiplied. This time your bases are different but your powers are same, so you can write it as a multiplied by b whole power m. For example, if you have 3 to the power 3 multiplied by 2 to the power 3, you can write it as 3 into 2 multiplied by to the power 3, that is 6 to the power 3. Okay, let's talk about the fourth rule. Again, your bases are different, but your power is same. So you can write it as a by b whole power m. Okay, let's talk about the next rule. Let's say you have been told that a by b whole has a power m. This is equal to b by a whole power minus m. Okay, is this okay? Did you understand this?
Yes.
Okay, let's talk about some more rules. Sixth one is basically a to the power 0 is 1 for a not equal to 0, right? This means that if you have 1 lakh to the power 0, that would be 1 because the power is 0. And if you have 0 to the power 0, that would be 0 because this rule does not hold for a equals 0, right? Okay, let's talk about the next rule. It is 1 to the power x equals 1. Now, if you have 1 and you have, let's say, 100 in the power, the answer would be 1, right? Let's talk about the next rule. So we have a to the m whole power n. So the outside power would be multiplied with the inside power, and that will give us a to the mn. Let's talk about ninth rule. Let's say you have a to the power x. You can write it as 1 over a to the power minus x. So this basically means that there's a connection in the fifth one and in the ninth one. Ninth basically means that when you take something from numerator to denominator, the power gets a negative sign. For example, if you have a to the minus x, it would become 1 over a to the x. Okay, so this is a rule. Whenever you change or move a number from numerator to denominator or denominator to numerator, its power is multiplied by minus 1. Let's talk about some examples over here. Let's say we have 3 to the power minus 2. It is equal to 1 over 3 square. Because here it was in the numerator, I've taken it to the denominator, so I will multiply the power with minus 1. For example, if we have 4 to the power 2, it would become 1 over 4 to the power minus 2. Right? Is this okay? Did you understand this?
Yes.
Okay, perfect. Okay, so let's talk about some more rules. Now, basically, technically, we are done with the rules, but another concept which you need to understand is that let's say you have been asked to find the value of x for such an equation. How do we go about this? Now, x is basically in the power. In order to find the value of x, what you need to do is you have to get the base 2 here, right? Right now, the base is 8 and the power is 1. But you want the base 2 here. So you know that 2 multiplied by 2 is 4 and that multiplied by 2 is 8, which means that 2 cube equals 8. So you can write this as 2 to the power x equals 2 to the power 3. Now you see that your bases are same. So you can just compare the powers, okay? When two expressions are same and when their bases are same, it means that their powers would also be same. So x would be equal to 3. This would be the answer. Okay. For example, let's say you have three to the power minus x as 1 by 9. So what would be the value of x? Again, you need to make comparisons in order to find the value of x. What you can do is, you can just do it this way. 3 to the power minus x, or maybe, yeah, equals 1 over, you have 9 here. You see that your base is 3. So you want 3 as your base everywhere. So what would be 9 with base 3? It would be 3 square. Again, things are very different. You cannot say that minus x equals 2. No. We need to take this to the numerator just so things are same. This would be 3 to the power minus x equals 3 to the power minus 2. And now you can just see that everything is same. Both the terms are equal. Your bases are same. This means that your powers would also be same. So it would be minus x equals minus 2. Minus and minus would be cancelled. And x would be equal to 2. So did you understand this question? All the students? Anything that you have not understood, please ask me.
No, ma'am, it's clear.
Okay, perfect. Acha, let's talk about some more questions which are related to this topic. Let's say you have 8 to the power 2 by 3. Okay. 8 to the power 2 by 3. Now we know that there was a rule saying that a to the power m whole bracket power n is basically a to the power m n, where m and n were being multiplied. So I can write it as a to the power 2 1 by 3. Now I can find 8 square. 8 square is basically 64, and 64 power 1 by 3 basically means cube root of 64. So what would be the value? The value would be, we know that 4 into 4 into 4 is 64. So this would be cube root of 4 cube. And again, I can write it as 4 cube multiplied by 1 by 3. That would be 4 cube into 1 by 3. Yes, you could have cancelled it directly as well. But since we are talking about the method, we are understanding the concept. So since this 3 and 3 can be cancelled, that is why the answer is 4. Yes, you could have cancelled here as well. But this is the logic. This is why the answer is 4, right? Did you understand this?
Yes, ma'am.
Okay. Let's talk about another example. That's example number 2. This time you have 64 power 2 by 3. Yes, okay. Now how are we going to solve this question? Yes, anyone?
64 power 2 into 1 by 3.
Okay, but okay, let's do it the way you are saying. 64 power 2 whole 1 by 3. Yes, that would have been 100% correct. But don't you think 64 into 64 would be very difficult, especially if you have to do it in P1, like without the calculator, right?
Yes.
So we can do the same thing, but other way around. 64 power 1 by 3 whole square. Now this is going to give me cube root of 64 whole square. We have just seen that 64 is 4 cube. So I can cancel these two out and I have 4 square, that is 16. right? So yes, Saneem, your method was 100% correct. But in order to do things quickly, just so they are less complicated, we have to be careful with our method. Okay. Let's say that you had a similar question. (64 power 3 by 2). Now again, if we do it this way, 64 power 3 whole 1 by 2, yes, that would be correct, but it would be very complicated. So it's much better that I take the square root first, that is 64 power 1 by 2 whole power 3. This would be the square root of 64 whole 3. I know that 64 is basically 8 square whole cube. I can cancel this out and now I have 8 cube, right? So 8 square is 64. 64 into 8 will give you 512. This would be the answer. So did you understand all this, all the students? Turhan, Saneem?
Yes.
Okay. Anything that you would like to ask? We have a new student as well. I don't know her name, but anything that you would like to ask? Anyone? Saneem, no question? Oh, sorry. Turhan, no questions?